first thing I want to do is look at yesterday's end of the delta math, because I was creeping on that, and there were red X's, and as I can see what you entered, I don't even remember specific people, but if you can't interpret the expression, today you're going to need to set it up. So, and your calculator is going to do all the math. So the issue isn't really about the doing of math, it's the interpretation of the math model, which is a way higher skill. But this one was one from Delta Math yesterday, so I want to make sure how you can help yourself if you're stuck either setting it up or interpreting one that is. So this says that we're looking at a 21-hour period at the rate of change of the number of the people in line. This is really important because what they're giving you right here is a rate of change. It's measured in people per hour. I would put a label on that either in your brain or on the paper. And then our change in time is an hourly change. These would cancel each other out. So I know my label, my 50 represents 50 what? People. Some people were clicking on, like they thought this was a rate that was 50. And so they said that the number of people was increasing because the 50 is positive, like that kind of thing. Once you integrate, you remove the rate. All right? So that 50 represents 50 people. There were 30 in line at time t equals 12. So I would consider that the start of the accumulation. So it started at 30 and then accumulated up to 50. So that 50 represents 50 people what? 50 people in line, correct? And then you need the time at the end of 21 hours. Perfect. Yeah, the next one I chose, there were 4 of them in there, but I just chose these 2 because they apply today. So this one, they tell me there's 155 deer already in the forest, but it's not in my model. So this 90 doesn't represent the total number of deer, correct? If it was the total number of deer, when I integrate my rate, which is in deer per, what is this, week, right? And weeks, that is 90 deer, but it's not 90 deer in the forest. It's what? 90 deer accumulated from hours 2 to 9. The number of deer, the total number, would be that. All right? So that's just 2 interpretations that I want you to know. Then the next thing we're going to do is hop in your notes really briefly. So I want you to, I have to page back through here. So I know this video, for those of you watching this because you weren't in classes, it's going to be long, but we're going to be working on homework and pausing. So, all right, so go to page, I got to go through here. I think we're on right close, right here. So we're still in the same section. Yesterday, we dealt with this accumulation model. And yesterday we dealt with this model, all right? Today, actually, we're going to talk about this one, and I want you to see what this is telling you. It's really telling you something I've been saying. Derivatives and integrals are inverse functions, so they undo each other. So that's why they're saying that when I take the derivative of this and the derivative of this, the derivative undoes the integral, and I just get the function back. That's what this is saying, that the derivative of an integral is like squaring a square root. It just undoes it. Don't let the x's and t's mess with your head. It really doesn't matter. I could put an x right here if it bugs you. It's just not generally how it's written. All right? So, basically, this one is saying a derivative what? Undoes a derivative. Exactly. And an integral undoes a derivative. They work both ways. So that's just really saying they're inverse operations. So what I want you to do is go to the example we skipped yesterday, which was example number 1, and it's in your note packet. So yesterday we didn't do this one. It's on page, I think, 17. Is that right? 16. Yeah. So here is sort of it's actually easier than what we were doing yesterday. It's just you have to understand the notation. Like if I were to say, what does G do? G accumulates area under the curve from 0 to whatever you put into it. If I were to ask you guys in the 8th grade, what does F do? You would say F multiplies multiplies by 8 and adds 1 to whatever you put into it. Okay? My function, g, is an accumulation of area under that curve. So when it asks me what's g of 0, I'm just supposed to integrate from 0 to 0 under the curve. You don't need to write that unless you want it on there. But what's the answer? 0. Yeah, I'm not going anywhere. There's no area. That's done. G of 1 is just saying now integrate from 0 to 1. So that's easy. I just look at that and I say from 0 to 1, there's a triangle, a 1 by 2 triangle, and I need to take half of it. So I just say 1. So I want you to write right here, area. The G function is just area. So you've been doing this, it just now has different notation. So G of 2 is just going to take my triangle that I already had, correct? And tack on how much more? 2, right? So G of 2 is going to be the triangle I already had. And again, all I'm doing is saying now go from 0 to 2. Well, since I already went from 0 to 1, I'll take that, I'll just add on, and I'm done. So the G of function just does what? Accumulates area from 0 to whatever you put into it. If I were to do G of 6, I would be doing the whole thing, but I would have a little shortcut in there, correct? So I'm going to take my 3 that I already have, right? And then I'd have this, right? But then what would this mark do? It would wipe each other out. So there it is. So that's what G does. The next question is, well, what does its derivative do? All right? So G is area. All right, so let's go up here. This is the most important thing you write on here is this. G equals area. G prime of x equals. What did I say happens when you do the derivative of the integral? It cancels each other out. So if I take the derivative of the left, I get G prime. If I take the derivative of the right, it undoes the integral, and I just get f of x. So when it says, what's G prime of 1, G prime in 1 is really just f of 1. What's f of 1? 2. Exactly. The G prime function is really just your point on the graph. So my given function's accumulating area. The derivative of it undoes it, so I'm just on the function, correct? So what would G prime of 6 be? -2, correct? I'm going to write equals, though, just so in case you look back at these notes for test studying. Where really just, it undoes the integral. So it's just -2. So not a whole lot of deep thought here, correct? On the bottom, I want you to cross this off. And I want you to do a G double prime of, I have to go to the graph and make sure, I can't just throw any number in there because I saw stuff I wouldn't be able to find. Because let's go take a look at, and again, this up at the top is really important. If G prime is F, what's G double? F prime. What would F prime be? Awesome. Slopes. Exactly. If you can interpret the language, the math is not the issue, correct? Can we find points on a curve? Yes. Can we find areas of rectangles? Yes. And can we find slopes? But I can actually only put one value. I think I have to do it a half because I don't know the slopes. Well, actually I know the slope at 1.5. It's 0. But let's do G double prime of a half. That would be F prime at a half. It would be the slope there. And I lost the graph. What was the slope at a half? Up 2 over how many? 1. All right, done. So we're going to stop just for a little bit, and you're going to work on number 1 of your packet. I'm going to just, all right, so the next thing we're going to do is we're going to go look at number 2 in the homework. And I'm trying to, because it's a long lesson, I'm trying to kill off some homework while we go through it. I don't like to give you guys too much homework. Say thanks, Rude. You're welcome. All right, I got to erase this from last hour. I guess I didn't erase it yet. All right. So, number 2 on the homework, I'm going to read it first. It says big G of x is accumulating area. So I have to think of this as an accumulation function. It's accumulating area under whatever this might make if I graph it. I'm supposed to find, let's change that to big G. I'm supposed to find where that function has a local maximum. So now I have to go back to chapter 5 and remember what happens. F has a relative maximum when F prime does what? Changes from positive to negative. So G, and I would write this, I'm going to do the explain first. G has a rel or local max when G prime changes, not changes signs, but changes from, let's do plus to minus just to kind of speed it up a little bit here. All right, that's my explanation. So I need to know what G prime is. I need a function for it. What will G prime be? What happens when I take the derivative of the integral? It now wipes it out. They're like squaring the square root. So I get the square root of, right, x to the 4th, because it says we're putting x in. So x to the 4th plus 1 plus x cubed minus 3x. So let's go write that on here. The derivative taking will undo the integral. So square root of x to the 4th. And you want to put t. Your calculator couldn't care less what variable you use, but it has x on it. So, why did I talk about the calculator? Because this is calculator active. So my thought process is done. The math is easy, right? So now I have to know with my calculator where this function changes signs. So what am I going to do with it? I'm going to go graph it. So go ahead and go to your calculator. Enter not the original function, but its derivative. Okay, so it's kind of like you're going to be looking at f prime from the last test. Go enter it, and remember before we hit graph, we always kind of think about our window. So once you've entered it, don't hit graph. Set your x's to go from -3 to 3. I just go by ones. And for your y-axis, because we just need to see where it crosses, maybe just -2 to 2 or -1 to 1. Doesn't matter because we're not looking at highs and lows or anything. And you should see your function crossing if I remember right from last hour, it crosses the x-axis 3 times, but only 1 time does it cross from above to below, correct? And that's what we're looking for. So let's write G prime equals this, right? And it changes from negative to positive at x equals, and there's one spot, you need to go calc 0 on that one spot. Last hour, I remember it's between 1 and 2, but I don't. That's all I got. 1 point what? Oh, sorry. Okay, then 0.350, right? All right. This occurs at 0.350. So this is kind of taking that derivative undoes its integral and intertwining it with last chapters. This is going to word problem you very soon. All right, so kind of know that when it discusses a derivative and you're given an integral, it wipes it out. Next step. While we're at it, I'm going to have your brain's going to be like this. It's on purpose. Now, because we're going to be combining all these skills in an FRQ at the end of the hour. All right, so for number 3, I want you to interpret this. It's like it was on Delta Math yesterday. What is O of T doing? And we'll do it together. All right, so when we're going to end the hour on a rate in, rate out FRQ. I always say, draw a cheesy picture. It is entering the tape at a rate. So this is a derivative right here. It's entering at a rate in gallons per hour. And then oil is being removed from the tank at a rate of L of T in gallons per hour. So wrap your head around the picture. I've got a tank. It's being filled with oil as trucks are filling their tanks with oil and driving it away. Correct? All right, and these guys are bringing it to the gas station. These guys are bringing it to the storage tank. Before we started charting this situation, was there any in there? There are already 2,000 gallons in there. All right, so this obviously represents the gallons in the tank, correct? What would this piece represent? If I integrated this function, it would represent the number of gallons that went in, correct? If I integrated this function, it would represent the number of gallons that what? Left. So when I write this expression, it's how much was there plus how much got put in minus how much that got removed. So really, this function, right, gives the gallons. All right, this was in gallons, and this one I'm integrating gallons per hour, is it? Right? Times hours. So it's the gallons in the tank, correct? At time what? Whatever you put in there. Yeah. If I want to know how many gallons are in the tank on week 5, I'd put 5 in there. Little calculator. All right, are we good with that? We're going to be combining all of this in a bit. So now, where are we going? I have to think of the order, like I'm hopping all over the place. Oh, I remember. We're going back to the notes. So out of the homework, you've got most of the first 3 should be done, right? Pretty much. Maybe a couple to clean up. We're going to go back in here and talk about, in your notes, example number 3, I think it is, that we skipped. I think it's on page 17. I'm not sure. I'm getting there, though. One more. Here it is. Your example 3 in your notes, page 17. Example 2 we did. If you want to write in a box, you can write on separate sheets. We did example 2 yesterday. We're trying to kind of do things separate, and then they're all going to mesh at the end of today. So now I've got a function of f prime, called f prime. This could have been last chapter, correct? What does this mean? Well, f prime is negative, f was decreasing, f was increasing, f was decreasing, and now when we integrate, we find how much it lost and then gained and then lost and then, correct? So we kind of have a similar situation. It says f of 0 is 3. What does that represent in the context of this problem? F of 0. Starting amount, right? Of whatever it was that was changing. We talked about snowfall yesterday. So at hour 0, there were 3 inches of snow. And then I lost some, gained some, lost some going forward. All right? It asks me to find the absolute max. So again, we're meshing chapter 5 with chapter 6. So 5 didn't go well. It's going to affect the 6 a little bit. On chapter 5, you guys are really listening, which is good. So it's a long lesson, but it's important. All right. We talked about how you get absolute maximums. Where can they occur? I call them candidates. At x equals what? Go ahead, Tim. Who goes on my candidate table? What'd you say? Nope. -6 for sure. 6. We always evaluate what? The endpoints. And keep in mind, I'm looking for an absolute max of f. F primes candidates would be -3 and 3. Correct? What else did we do? So we would make a table, and we would see, well, maybe that thing was at a maximum before or at the very end, or at the very beginning. It's very possible. In many real-life situations, if there's always more people entering the hospital than leaving due to COVID, correct? The max will be at the end. If it's reversed, they're always leaving the hospital faster than they're going in, then the max would be what? The endpoints are very often the winners, so you have to consider them. But what else do you have to consider? The relative extrema, right? Which we called, you have to find the critical values, correct? So up here, there are critical values. It's where f prime equals what? There's one here, 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 here. Right now, there's 6 candidates. I can quickly eliminate 2 of them. Which 2 will I not put on my table? I could, and I won't get docked for it. But -4 would be the location of a relative min, with no way they're going to win absolute max, correct? Who else is out? 2. Now, if you do that, this is where you have to listen carefully. If you do that on the AP test, if you don't put them on your table, so a lot of times, like in Calc BC, when we get these, they'll just do all 6 of them because they've learned that to explain why they're not using the other ones takes just as much time. But you would have to say, I don't need to consider these because they're the locations of what? relative mins, and by the time you're done writing that, the math, it just kind of depends. You decide. I'm only going to consider those 4. All right. So yesterday we talked about the common sense and the math of it, right? Agreed? Yes? They gave me an anchor up here that f of 0 was what? Let's talk about snowfall. Okay? Let's just go common sense because it's really easy to use common sense to go forward. I started with 3, then I lost some, correct? So let's go to what's happening at 5 because it's easy to go to the right. I started at 3. How much did I lose right in here? You have to calculate it with geometry, but that would be a quantitative loss of how much? 1/4 pi times 2 squared. It'd just be pi. Okay? 3 minus pi. Then I gained this. So I'm just going to go forward and add that amount of snow on to my 3 inches of snow. So I had 3 inches, pi melted, and then it snowed. How much is that guy? 3, right? So this guy would just be 6 minus pi. Cool. That was the common sense. Okay? What other one do you think I might as well do as common sense since I've gone this far? Yeah, at 6. I might as well take how much I had at 5 and do what? Shave off that half of a triangle, right? That'd be a half. Is that just a half? Yes. Okay? One of these is now not going to be a possible absolute max. One is smaller than the other. Which one's up? There. I'm just going to go like that. I don't know that you should. You want your AP reader to see those calculations. But if you did, that's okay. Don't scribble. They'll need to see it. You don't need actual numbers because this wouldn't be calculator active. So you're just expected to compare quantities. Going backwards can be harder. Okay? I want you to try to go backwards to get the amount at -2. And if you can't do it right, you can't use the shortcut. Okay? So I want to know, again, I'm going back to my anchor. If there were 3 inches of snow after this happened, what was there back then? So you have to kind of be careful, right? If you're using common sense, you better do it correctly. My anchor was at 3 after I lost how much? Pi. So what should I put on here? Plus pi. How many did that correctly? Then your shortcut is okay. All right? But if it's not correct, then I'm just going to show you real quickly what you would need to do. You would say I need to integrate from my anchors at 0 and my other x values at -2. I like to go like this under the curve, right? And we said it equals the antiderivative at the top minus the antiderivative at the bottom. If you were absent yesterday, you missed a whole very important thing. They gave me this was what? I can calculate this. Correct? I just go up to the graph and I go from -2 to 0. And you guys told me that was pi, right? Pi. How would I solve for this? I'd add it over here and then subtract. And what would I get? 3 minus pi. It's a lot more funky monkey stuff, but does it always work? Yes. Okay, so back here. Since I already know at -2 I is at 3 minus pi, let's keep going from there. That's how much it had after gaining this. So to get back, what do I need to do with it? Subtract it off. How much is that? 1. Okay? And now to go back to 6, I lost this much and got that. So what do I have to do?
Is it 3 plus pi minus 1?
Where am I? -6 was 3 plus pi. Thank you. And then I have to add this last guy on. What's the area of that guy? Plus 2. This guy ends up being 4 plus pi when I'm done. That was the common sense of it. If you're like, yeah, I got that now, do it. It's so accurate. It's so much shorter. So basically, when you go forward, you do it as it is. When you go backwards, what do you do? The opposite. Yeah. I have $10 in my pocket after I earned 8. Well, then I must have had 2. Correct? So you go back. All right, now I answer the question, which of my final things is the largest? This guy, isn't it? And wasn't that an endpoint? So the student who doesn't consider endpoints is kind of lost on this one. Like there's not much you can salvage. But you would have to say the absolute max. Did it say where or what is it? What is it? What is it? What's the absolute max? 4 plus pi. So you'd say the absolute max is 4 plus pi at x equals negative 6. What do you think about that one? Okay, now it's all coming to a head. We're going to go to example. I don't like the mean one. We'll never do it. It's just, we're going to go to this guy. Everything's going to come into play on this FRQ. Every year since I have had AP Calc, there's been a graph analysis question, like on the last chapter test, and one of the 6 FRQs is almost always what I call a rate in, rate out. And on Monday, I'm going to do the 2017 one with you. I'm going to put you in groups to do 2 like actual ones. One's the year of the food, so is bananas being stocked on a shelf and people taking them, and there's a certain amount when the store opens. It's stupid. Who would ever do that with bananas, right? And I think I told you that was the same year they had to find the internal temperature of a potato, which you would never do. You do like time of death and murder scene for that skill. Like, why would I just stick a thermometer in? Or I kind of squeeze it and wasn't gonna put it back in. Right? You would use calculus with your potato. How hot is it in there? Anyway. But there's always this type of a question. I took an old zoo one and I added a few more layers to it. So they're usually worth 9 points. Do you guys, have I talked about national averages? Do you know what they run in the room? 3. Yeah. Actually 2 to 4. So I always say around 3 is, if you want to get a 3 on the AP exam, you're shooting for 3s and about half the multiple choice. If you want to do better, you're shooting for 4s and 5s and more multiple choice. If you want to get a 5, you're shooting for 6 and 7s, right? And you want to get about 70% of the multiple choice. So that's kind of how it goes. 5 corresponds to about 70% of it being correct. So, should you understand all parts of this right now? No. But my hope is that by the time we do a practice one closer to the test next semester, that a lot of you are at that 7 out of 9. I don't like to shoot for 3s. 3s get degrees, but you don't know much. All right. So, we've got a zoo. I'm going to just draw my zoo. I want to get my brain wrapped around this problem because it's going to determine whether I get college credit or not and save thousands of dollars. So I might as well draw it. They are entering the zoo at a rate of E of t. What was the most important word I just said? Rate. Okay? Boom. This is a derivative. Okay? It is not number of people. It's people per what? Hour. Okay? They're also leaving the zoo. So at a zoo, people are coming in, people are leaving. Okay? They're leaving at these 2 rates and coming at these rates. All right, there it is. Does it say how many are in the zoo when we start? But what can we kind of assume when they open the doors? Probably 0, yeah. So if they don't tell you it's a 0, logically. All right, so first thing I would do is go to my calculator, because this would definitely be calculator active. There's no way they'd make you calculate arctan and natural log without a calculator. So you're immediately going to go put this in your Y1. You're going to look at it 3 times. Go do it. And I have it entered on mine too, so I'll pop mine up. Watch your parentheses. Why did I say you're going to look at it 3 times? You're going to use these in 4 different parts. You're trying to get 9 points. If you enter one of them wrong, you're done. Like you can't, you'll get all those. I told you one of my BC kids did that a couple weeks ago, didn't I? I might have told my 3rd hour, but John Palmer did it. He always scores like 9s and 8s. He got like a 3 because he typed one of the parametric equations in wrong, so all of his movement was off. I said, you never get below. What happened? He goes, I typed it in wrong. I'm like, oh. So you're going to type that in your Y1, and you're going to look at it a couple times. Then you're going to type the other one in your Y2, and you're going to look at it. Double check it. Because if we're going to use our calculator, and we're going to use it really fast, actually, this better be right. The math is always easy for these. It's the do you understand the problem part. What do I enter on my calculator? Or did I give you guys enough time to enter that? Okay, so the first question says, how many people? So the minute they're talking about people, right, and not people per hour, what do I know I'm going to need to do? How do I remove the rate? Integrate. I'm going to integrate, correct? To go from people per hour to people, I need to integrate. So you're going to draw a little integral symbol right here. Okay? It only wants to know how many entered. What am I going to integrate? Just what? E of t. Don't rewrite the whole function. It's already defined. So you're going to integrate E of t dt from where to where? 0 to 4. You have to set that integral up. You can't just go to your calculator. You do have to write the setup down. So you're going to write that down, and then you're going to go enter it on your calculator. What button are you going to hit? Math 9. Exactly. We are integrating. Oops. Second quit. I didn't mean to put that in there. Delete. We're clear. So we are going to math, and we are going to 9, and we're going to go from 0 to 4, right? And then I don't want to type that in. I already double, triple checked it. I'm going to bring it in with what button? Vars. It's when you hit your Y vars, right? And you guys are always functions until you get to Calc 2. They're in Polar right now. So in Calc 2, so they go down a couple levels. But you're just going to go like this. You're going to pick the first one because that was my entering function. And what do I put over here? X, and I hit enter. And that's what you need to write down. But replace the Y1 with the E of t. Okay? 203.068. It didn't ask for the label, which means if you put it and it's wrong or you don't put it, you won't be docked. But what is it? 203 what? People. I integrated my people per hour. All right. Let's go to the next one. It says 20%. So I'm just going to start picking this apart. I know what 21% is in math. 20% is in math. It's 0.2, correct? Of means multiply. What am I multiplying? The people who leave the zoo. 20% of the people who leave get selected to get a special ticket for free entry the next time. Okay? So now I'm going to take and write a math model for that. I don't have to do the math. I can tell my calculator how to do the math. So I'm going to tell my calculator to take 20% of the people, so I need to integrate, who leave the zoo. So what am I going to put here? L of t, right? And what are my limits? 0 to 5? No. 5 o'clock is hour 9, correct? And they tell me that, so that's actually nice. Again, I got the stem of this problem from an actual FRQ. I just added stuff to it. All right, and where do I go right now? Off on my calculator, okay? Equals. So I don't really care what it equals. I know you got. If you got the first entry right, it's fine. So let's pick up the pace here a little bit. So my next question is C. Now it starts to get, all right, what's going on here? So you got to really, I told you the very end of the hour is the most important one. All right, are you ready? They're giving me a new function. I better wrap my brain around what that function's doing. Okay? Because I'm supposed to calculate n of 10. Agreed? Well, it's easy to calculate. I just put a 10 in everywhere the t's are. So the math of it's easy. And I even put those on my calculator. So this one I do want you to do on your calculator. N of 10 means put a 10 in the n. Well, that's n. So I'll just go to my calculator. I'll bring these in with my bars. So I don't even have to worry about parentheses or anything. And my calculator will give me the number, and I'll write it down, and I'll get one of the points. But now I have to know what that number is. That's the hard part. I don't know what it is. You know, like the right, I put a Y2 in here. Lots of clicking. It's thinking 273.635. All right, 273.635. Now we have to think about what is this 273.635. Let's pick it apart. Okay, I integrated the people per hour, correct? So this represents 273.635 what? People. That's not enough. Remember I told you you need nouns, units, time. The people, what? The people what? The people who went in, the people who left, the people who are there, the people who are waiting in line. What are they? The people what? In the zoo. Yeah. Because I took how many people entered, and then I subtracted how many people what? Left. So their difference would be the ones still in the zoo. Okay? So 200 people in the zoo. Is that enough? No, you've been well trained, right? I am a good trainer. You don't listen to me. That's not so great. People in the zoo, what do I need to add to it? At t equals 10. I would do that in case you convert the time on. Like it's the 10th hour after it opened. I don't even remember when it opened. So 8 o'clock. Yeah, so what time is it? 6 p.m. But then don't bother. Just put that and you'll be good. All right, now the culmination of everything. So if you at all tuned out, this is it. All right? This is always on every rate in, rate out question, finding the max time when something was at the max or the minimum amount. On Monday, we're going to talk about a gravel pit, which is nice. It's an actual AP one, but Elk River has that huge gravel pit, right? So there's always trucks going and bringing unprocessed gravel, and then it gets processed and trucks take it away, right? So that makes sense. There's always a question about when is that gravel at its absolute most or absolute least. So this is asking me, when will I have the most people in the zoo? All right, and I'll be able to know how many there are. Okay, so when I'm asked for absolute extrema, I immediately draw a table. My time is going in, my number of people in the zoo, which is the function that was defined up here. That's where if I didn't know what that function was, I would, right? I'm going to write that down again. It was n of t was equal to, integrated, I got how many people entered. And you can put t's or x's, it really, they don't care. But this is from 0 to t, so I'm just going to use t's, even though the model has x's. And then I'm going to subtract off. Do you notice what I did? I split it into two pieces because I think it makes more sense. Amount in, amount out. They wrote it in one. It doesn't matter, but I think this makes more sense. So there I go. Who am I going to consider first? At the start, but there wasn't anyone there. Just don't. Who am I going to consider second? 12. How am I going to calculate it? Go plug it in. It's easy, right? But I have to know to use this function. I have to know to plug in the endpoints when I calculate or do the math. I will replace the t's with 12s, and I'll math 9, either their difference as 1. I like to split it up, even though it's more typing. It makes more sense to me. This is how many went in, minus this is how many went out. What's left? I don't know what that is. I know it didn't win last hour, but it is a candidate, and I want to talk about how it could win. Okay? How many people? 200 something. To what? 0.505. Okay. Now, that is only a winner if the people entering rate, right, was always greater than the people leaving, correct? Would that be true? Right? It's always, there's always more people going in than going out. Then I would have a max at the end. Right? But if at any point those cross paths. So where else goes on here? What else? We call them critical values, but they're anywhere where the derivative equals 0. The derivative of what function? And t. Perfect. I need to find, well, where does my derivative equal 0? This is calculator active. I don't have to take a derivative like manually, but I have to know what would happen if I took the derivative of the integral. What would I get? The original function. Yeah, the derivative undoes it. What would I get if I took the derivative of this integral? Agreed? What would have to happen for that to happen? Wouldn't they have to be the same? And again, that makes sense, because if they were never at one point the same, which means they don't cross, then they're either always entering faster and the max is at the end, or they're always leaving and the max is at the beginning. So I need to figure out somehow with my calculator where E of t equals L of t. It's not hard to calculate. It's hard to figure out what to calculate. Does this make sense? So what am I going to do on my calculator real quickly? What are you going to do? You're going to go graph them, right? Don't just hit graph right now, though, because your graph's going to be a hot mess. You're going to go sit in your window. So we'll talk about that. What are you going to set your x's to go from? 0 to 12. The y's are a little trickier because I know it's in the hundreds, correct? What would be a good way to get a good wrap around maybe how, you could go trial and error, but that sucks up time. Doesn't your calculator make tables? Right? If you set yours to go by ones, maybe like hit second table set, and if you go back out of manual or whatever, you can go look at your table and just see, oh, how high are they getting? I think last hour we decided we better get up to about 500 or 400 because it was, is there anything over 4? Look at your table though when you're trying to structure that y-axis. Otherwise you're going to hit graph, not see it. And then you're going to tweak it and not see it. And then tweak it and then maybe the 5th time you're like, oh, finally, there it is. Just go to your table. You need to get to the hundreds. So I would go from 0 to 12 by ones. And I go from 0 to, did anyone check their table? How high do they get? Do they get past 300? Do you know how to set your table? They don't go past? So what should we go to, 400? Maybe by 40s? Try that. If we can't see it, I guess we'll have to tweak it. But according to what these guys are saying. So go set your table and hit graph. If I remember right from last hour, they sort of started out the same. One went like that. The rate in one did. And then I think the rate out one kind of went like, am I right? I'm trying to see it in my head from last hour. Sort of. Yeah, now again, you might want to stretch that out a little bit. It looks like we didn't have to get that far up, correct? Right? Maybe you want to tweak that, go from 0 to maybe 300 by 30s or something. But either way, this means rate in, right? And it's more than rate out. So the number of people is increasing till it hits here, then it decreases. You need to calculate that spot. And I remember it's 8 point something. You're my second hour, so it's nice to have a reference. What is it? 134. Okay. What am I going to do with that 8.134? Plug it in to what? The function I'm trying to maximize. It's not f of x anymore. What is it? Number of people in the zoo. Where is it? They gave it to me, and I'm going to go put it in. Whoopsie, sorry. Right here. The number of people in the zoo would be how many went in minus how many went out. 8.134, 8.134. Bring them in with bars and y bars. Your calculator does the heavy lifting. You have to do the heavy thinking. That was a very good phrase. I'm proud of myself. All right. I don't know what that is, but it does end up being the most from last hour. I'll let you guys calculate it, because actually, if you don't know how to work your calculator, your first 2 FRQs will be zeros and then maybe 1. There's only 2 with a calculator, but you need it on every single piece. Did you finish? Did you get it? Is there 281.117? Yes. All right, so then you'd have to actually answer the question. So if you understood all of that, that's awesome. What did I say national averages run? 3. And I pumped this one up a little bit. I added a couple extra things in there. Did we do part C? We didn't do the second part of it. I would have lost some points. I would have been mad. This is when you get your test back and you're like, oh, really? What else did it tell me to do? M prime, right? Well, you might say, I don't know how to do n prime. You do, and you don't even need to hit math 8. Because what happens when I do the derivative of this? It cancels it out, so that'd be e of 10. What happens when I do the derivative of my integral? Cancels it out. You just have to subtract those 2. Don't bother. Last hour we got a negative 6 point some stuff. It's more the interpretation that I want. Okay? So if the derivative of my people in the zoo function is negative, right? That would be the rate that the people are Yes. It'd be the number of people in the zoo is decreasing by 6 point blah 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 people per hour. Because now I had people function and now I took a derivative, so I'm back to people per hour at what? T equals 10. Okay, so my noun is the people in the zoo. I took its derivative, so the rate, right? The people in the zoo is changing at a rate of negative or decreasing. We're done. So your assignment is to finish the other half of this. There is a key though. The most important